Let's start with the objectives of this tutorial. Refraction of sound examples are as follows. Refraction of sound waves while traveling over water. Refraction of sound causes difference in hearing ability. Refraction of sound used in sea exploration. Refraction of sound waves while traveling over water. The refraction of sound waves is followed by a change in the direction of the waves while going through a change in their medium. In addition to this, the sound waves also face a change in their speed and wavelength. So we can say that whenever a wave changes its medium, it undergoes refraction. Refraction of sound waves is seen most commonly in our surroundings. One of the best examples to explain the refraction of sound waves is when the sound waves travel over a water body and undergo a medium change, showing variations consequently. Here we can see that when a wave travels over a water body, it is traveling in the air only. It does not change its medium, but the air over the water itself has varying properties. And because of it goes through refraction, and this can be explained further. As we know, water has a moderating effect on the air above the water. The air mass occupying the area above water is comparatively cooler than the air from the water body. And we also know that sound waves tend to slow down their speed while traveling in a cooler medium than a warmer medium. And because of this, the wavefronts formed above the water body tend to slow down, whereas wavefronts far from water body speed ups. And due to its consequences, when sound waves move over a water body, it gets refracted towards the water body by these variations in air properties. This can be more briefly explained by taking one more example. This occurs in sound waves traveling over oceans. Usually, the temperature of oceanic water decreases while going in depth. This causes downward refraction of a sound wave that originates within/beneath the water body, which is totally opposite of the refraction of the sound wave mentioned above. Many marine experts find this refraction of the sound wave as an advantage that helps marine organisms to travel or propagate. For example, whales and dolphins can communicate over a considerable distance because of this property. In addition to marine organisms, it is also valuable for navigators traveling in oceans. These refractions from beneath create a shadow region, which helps identify a distant object. Refraction of sound causes difference in hearing ability. Refraction of the sound wave causes some difference in our hearing ability. Let us understand how the refraction of sound waves causes this. We all would have observed that we can hear more clearly during the night than daytime. This happens because, during the daytime, the air mass, which is close to the Earth's surface, is warmer than air mass on some height. Whereas during the night, the air mass close to Earth gets cooler than air mass at an altitude. This change in temperature inversion happens because of insolation. As we know, the Earth's source of energy is the sun. The energy from the sun is trapped in our atmosphere during the daytime because the landmass gets heated, and as a result, it heats the surmass close to it. Whereas in the night, this pattern changes because there is no insolation. As mentioned above, sound waves travel faster in warmer air than cooler air. So during the daytime, the sound waves moving will get refracted upwards and will move a short distance on the Earth's surface. Whereas during the night, the sound waves are refracted towards the Earth, and as a result, they will travel a longer distance over the Earth's surface. However, when there is a high cloud cover during the night period, we can find temperature inversion occurring. In a temperature inversion, while moving up an altitude, the air temperature is seen to be increased. Due to this, the sound waves traveling tends to refract towards the Earth's surface. This temperature inversion only causes the sound waves to travel a long distance. And consequently, people can hear the sound more clearly even after a long distance, much more clearly. Similarly, the refraction of sound waves causes a difference in hearing ability on windy days. This happens during a windy day when sound waves undergo refraction. The wind flowing faster at higher altitudes results in an effective change in the speed of sound in comparison to sound waves traveling close to the plane surface. When a person speaks during a windy day, the sound waves get refracted downwards with the wind to planes. This causes to carry sound waves over a long distance even in the daytime due to winds. Refraction of sound used in sea exploration. Sea exploration has become easy due to refraction, reflection, diffraction, etc. One of the methods used while sea exploration is sonar, which helps to identify the distance in the water. Other than this, identifying gas reserves, petroleum, fossils, etc. They are also explored by using these phenomena. As we know, the dead components of marine organism over 1 million years gets deposited in ocean beds. Due to the heat and pressure they face, they get converted into resources for today's world. To discover these resources in ocean beds, refraction of sound waves is also used. This petroleum created in ocean's beds seeps into empty spaces and rocks around it. And a solid sedimentary layer is above them, which does not allow them to flow or seep. Seismic reflection and refraction explore these reserves in the marine bed layer. In this echo, the sounding is used to measure the depth of the beds. And accordingly, sound impulses from ships are released in water, which gets reflected from ocean's beds and reaches back to ship. And the time taken by these sound waves to travel back and forth is then used to determine the depth of the ocean bed containing resources. During this process, the sound waves released get reflected and refracted from the ocean beds. And due to the refraction of sound waves, they also get passed on to different layers of the ocean's beds. And due to this refraction, the sound waves go in a complex way, which helps determine the density of each layer. By following this information and many other processes, the resources are allocated in the ocean beds. The features provided by the refraction of sound waves indicated reserves, as they too have different densities. Please visit our website lambdageeks.com for more articles on technology, engineering, mathematics, and various other domains. Scientific calculator and many more other tools.